This video is going to cover the three basic diagrams you can use to solve probability questions. The three diagrams are a possibility space diagram, a Venn diagram, and a tree diagram. Imagine that you have two tetrahedra, each with the numbers 1, 2, 3 and 4 on the faces. What's the probability that the total, when these two tetrahedra are thrown, the total is more than 4? We can answer this by drawing a possibility space diagram. So here we've got the possible numbers that you can obtain when you throw these tetrahedra, 1, 2, 3, 4. And we're talking about the totals, so we're going to add these numbers up. And what are the possible totals? Well, 1 and 1 is 2, 2 and 1 is 3, and so on. So we get all the possible totals when two tetrahedra are thrown. So this shows a possibility space diagram. It shows the possibilities in a diagram. So what are the ways in which we can get a total of more than 4? Well, we could have a 4 and a 4, a 4 and a 3, 4 and a 2, 4 and a 1, 3 and a 2, 3 and a 3, 3 and a 4, and so on. So all these numbers I'm circling show the outcomes when two tetrahedra are thrown and the total score is more than 4. So the probability the total is more than 4 is the number of ways of obtaining a total more than 4. Well, I've put a circle around 10 of these numbers. And how many possible ways were there altogether? Well, there were 16 possible ways. There were 16 numbers shown in the diagram, and 10 of them the total is more than 4. So the probability the total is more than 4 is 10 over 16, which cancels down to be 5 over 8. Here's an example where a Venn diagram can help. There's 275 people asked whether they study maths, physics, chemistry, and in what combinations. One person of these 275 does maths, physics and chemistry. 65 people do maths and physics. 10 people do physics and chemistry. 30 people do maths and chemistry. 15 people do physics only. 20 people do maths only. And 35 people do chemistry only. What's the probability that one person is studying physics? If we pick a person at random, what's the probability they study physics? Not physics only, but they study physics either by itself, or with chemistry, or with maths, or with all three. So in order to answer this question, we can draw a Venn diagram. And each circle represents the number of people that are taking maths, physics and chemistry. So this area here is the overlap of all three subjects. So how many people are taking all three subjects? That's 1. So I'm going to put the number 1 in there. Now there's 65 people are doing maths and physics. So in this region here, there's going to be 65 people, because that's the overlap between maths and physics. So there's got to be 65 in there. There's already one person, so that must leave 64 people that are doing maths and physics but not chemistry. There's 10 people doing physics and chemistry. So in this whole region here, there's got to be 10 people. Well, one's already in this section here, so here there's got to be 9. 30 people are doing maths and chemistry. So in this region here, there's got to be 30 people. One's already taken up there, so that leaves 29 people. Now 15 people are studying physics only, I should say. 15 people are studying physics only. So in this section here, there's 15 people. 20 people are doing maths only, and 35 people are doing chemistry only. And there's 275 people altogether. So what do these numbers add up to? That's 193. So that means that if we draw a large rectangle around the whole lot, that there's going to be 82 people that are not studying anything, any of these three subjects. So how many people are studying physics altogether? Well, it's 15, 64, 1 and 9. Those numbers add up to 89. So the probability that somebody is studying physics is 89 out of 275. Now, not all of these questions are the same, but this is a fairly common type of question, and it helps very much when you know the number studying all three to start in the middle and work outwards. But you need to read the question carefully because not all these questions are the same. The third example is making use of a tree diagram. Suppose you've got 5 red beads and 4 blue beads in a bag, and 2 beads are taken out and not replaced. What's the probability that the 2 beads you get are of a different colour? Well, the branches of the tree diagram, the first one is going to show what happens in the first event. The first event is the first bead taken out. There's 5 red beads out of 9, and there's 4 blue beads out of 9. So the first branch, this section here, shows the probabilities for the first bead taken out. After that, we could have another red bead, or we could have another blue bead, we could have another red bead or a blue bead. Now, if the beads are replaced, then these probabilities here are going to be the same: 5 ninths, 4 ninths, 5 ninths, 4 ninths. But in this example, the beads are not replaced. So we've had a bead taken out. It's this situation here, at this point here, it's a red bead that's taken out. So there's only 4 red beads left out of 8 altogether. So that probability there is 4 out of 8. We've taken out a red bead at this point. There's still 4 blue beads left. So this probability here is also 4 out of 8. But it didn't have to be a red bead to start off with. It could have been a blue bead. So we took out a blue bead. How many red beads are left? Well, there's still 5 left. So that's 5 out of 8. If you've taken out a blue bead, there's now only 3 blue beads left. Now the probabilities of getting 2 red beads are these probabilities multiplied together. So that's 20 out of 72. 5 ninths times 4 eighths, that's also 20 out of 72. That's also 20 out of 72, and this is 12 out of 72. As a check, 20 plus 20 plus 20, that's 60, plus 12, that's 72. So these numbers add up to 72 over 72, in other words 1. We've exhausted all the possibilities here. These two events here are where the beads are of a different colour. So 20 out of 72 plus another 20 out of 72, the probability the beads are of a different colour is 40 out of 72, and that cancels down to be 5 ninths.